Okay, good day to you all. Welcome to today's class. We are looking at partial fractions. We are looking at repeated linear factors. So this is about repeated linear factors. So what do we mean by repeated linear factors? It's just here at the bottom. If you were to look at this denominator, this is x minus 2, then in brackets squared. So meaning that this linear factor that you are seeing here in brackets x minus 2 is being repeated twice. This is why we call it repeated linear factor. Now, how do we resolve such in partial fractions? Okay, so say this is just a 7x minus 11, everything divided by x minus 2, then in brackets squared, which is equal to. So what I was doing, I was just rewriting this here so that I get to start solving. Okay, so now, of course, we are saying for the partial fractions, we should have a degree. That is the numerator should always have a degree less than that of the denominator. Then the denominator should always have at least a degree of 1, like that. Okay, it should have a degree of 1. That's what we are aiming for. So we'll put constants here. The letters A, we use letters A. Then we'll say x minus 2. Okay, so now we are assuming to say the original denominator for this function is just x minus 2 before it was repeated. This is why we've written it like that. Then plus a b over x minus 2, and then this time around now we write the repeated one. Okay, we start with the original denominator before it became repeated. Then on the other side we must show to say now it was repeated. This is how we separate this in repeated linear factors. Okay, so now many of you would ask me to say, I've said the degree of the denominator should always be 1, and then that of the numerator should be less than that of the denominator. This is why we put constants here. But why are we having a squared here? No, this doesn't matter. We are only focusing in the linear factor that is in the brackets. And then if you check where there is x here, the degree of this x is a 1. Okay, and not this here. Okay, thank you. So now we are resolving that into partial fractions. So now we want to get rid of the denominators. So what we do there is we can multiply by the common denominator there, which is x minus 2 in brackets then squared, like that. So if you multiply this times that, it will cancel out because they are the same. So you only have a 7x minus 11, like that, which is equal to the x minus 2 squared times this. The x minus 2 go, because this has only been raised to an exponent of 1. So you have 1 remaining here, x minus 2 remaining multiplied by a. So you have a times x minus 2 in brackets, then plus a b, okay, because this is x minus 2 squared and x minus 2 squared. So this and that will cancel out. You only remain with a b. Now, we can work out this. So this will just be a 7x minus 11, which is just equal to a times x, that is ax, minus a times 2, that is 2a, plus a b, like that. So now, for this one, we can just go direct and assign values so that we get the values of our constants a and b. So if you look at this, we're looking at where we have the variable of x. Okay, so this one has got a variable of x. On the other side of the equation, we have 7. It has a variable of x. So now we can just pick out the coefficients for this. So we'll say this is just a being equal to 7, like that. Okay, we've just picked out the coefficients direct, like that. A is equal to 7 because the coefficient of x here is a, the coefficient of x here is 7. So we are picking this because it has x, so we just say 7 is equal to a, we just assign them direct. Then we come to this one. This one here, these are just constants. A is a constant, b is a constant, negative 2 is also a constant. We don't have any variable here for this one. So we check on the left hand side as well of the equation, you find that we have negative 11 as our constant. So just like we did for this one, we can assign this value to this constant. So that will form an equation. You have a negative 2a plus b being equal to a negative 11, like that. So what you are doing here, you are looking for the value of b. We already know what the value of a is, so we'll make a replacement where there is a. You have a negative 2 in brackets 7, like that, plus b, which is equal to negative 11. So now negative 2 times 7, that is a negative 14 plus b, which is equal to a negative 11. So we are looking for what b is, meaning that we have to make b to be the subject of the formula. So we are transferring this negative 14 onto the other side. Now, once this goes onto the other side, we are taking its additive inverse, meaning that if it is a negative like it is, it turns out to be a positive. So we have b remaining alone, which is equal to positive 14 minus 11. So we have our value of b like that being equal to, so 14 minus 11, that is a 3, positive 3 like that. So b is equal to positive 3. So now we come back here and do the replacements. You have a 7x minus 11 divided by x minus 2 in brackets squared, which is just equal to, where there is a, we are replacing with a value, which this is 7 over x minus 2 like that. Then plus you have b, the value of b, that is a 3, divided by x minus 2 in brackets squared like that. So we've resolved that one into partial fractions. We end there. Thank you all for your time. Be on the lookout for other questions on partial fractions. Thank you.